Hello and welcome to another video. Today we will look into the modeling of a system. So one of the prime tasks or important tasks in a control engineering is to model a system to get a mathematical relation between input and the output variable. So we will start with there are different kinds of systems, electrical system, mechanical system, or flow kind of system. So we will start with electrical systems. So every system is modeled by basic basic physical laws governing that system. So in an electrical system, the basic laws that governing the system are the Kirchhoff's law, Kirchhoff's current law, and Kirchhoff's voltage law. So what does Kirchhoff's current law state? Kirchhoff's current law state the algebraic sum of the currents in a network of conductors meeting at a point is zero. That means the current entering a junction is equal to current leaving that junction. So Kirchhoff's current law states that the algebraic sum of the current in a network of conductors meeting at a point is zero. So here, suppose this is the point and the current entering the junction is I1 and I2, and the current leaving the junction is I3, then I3 is equal to I1 plus I2. So the sum of all the current meeting at a point is equal to zero. Similarly, in a voltage, Kirchhoff's voltage law, the directed sum of the potential difference or the voltages around a closed loop is zero. Suppose you have Kirchhoff's voltage law states that the directed sum of the potential differences or the voltages around a closed loop is zero. So here the directed sum means the positive and the negative sign that I have marked here. So here V2 and V3 have same positive and negative. So V2 plus V3 minus V1 will be equal to 0. So this is the Kirchhoff's voltage law, or in other words, it is V1 equal to V2 plus V3. So as a first example, we will derive the mathematical model of an RL network in parallel. So electrical systems, a basic electrical system consists of mainly resistors, inductors, capacitors, apart from the voltage source. So here we will consider resistor and an inductor which are kept in parallel. This R component is the resistor and this L component is the inductance. So we need to derive the mathematical model of that mentioned with the decimal. Here, in most cases, they will specify what are the inputs and the output. Here, the input is the supply voltage that is given at these 2 points, that is U1. The output is the current through the inductor, IL. So IR is the current through the resistor and I is the total current. So to begin with the modeling, we will start with the basic laws. Here, consider this junction. The current that is entering the junction is I, and the current leaving the junction is IR and IL. So this is how we start the modeling. The current, we use Kirchhoff's current law and we write I equal to IR plus IL. Now IR, what is IR? What is the current through the resistor? It's nothing but the voltage. IR is equal to voltage across the resistor divided by the resistance value. Similarly, the current through the inductor is 1 by L integral of voltage across the inductor. And we should note that these three elements, this, and this, these three are parallel. So the input supply voltage U1 is parallel to resistor as well as the inductor. So voltages in parallel are equal. U1 is equal to UR is equal to UL, or so the voltages U1 is equal to voltage across the resistor and the voltage across the inductor. So this equations becomes IR, and IL equation becomes IR is equal to U1 by R, and IL is equal to 1 by L integral of U1. Instead of VL, I have written U1. Instead of VR, I have written U1. So what does a model mean? A model means the relation between the output and the input. So here, we have a relation between the output and the input. If we differentiate both sides, it becomes EIL by dt equal to 1 by L. So this gives the relation between the output and the input. So that is how you model a RL network. This is one way of modeling. There are plenty of ways of modeling a system. This is one way of modeling a system and the relation between the output and the input. Now we look into another example of an RC network. So here we have a resistor and a capacitor which are kept in parallel, and we need to derive the relation between the input and the output. Here again we have this node and the current entering that node by Kirchhoff's current law. The current entering that node is equal to current leaving that node. So I equal to IR plus IC, and we write the equation of IR. What is IR? IR is VR divided by R, and IC equal to C dVC by dt, where C is the value of the capacitance and Vc is the voltage across the capacitor. Now substituting it, and we note that voltage, these three elements, this input voltage is kept in parallel to the resistor and capacitor. So U1 is equal to, voltages in parallel are equal, U1 equal to VR, that is equal to Vc. So the equations above will become IR is equal to U1 by R, and IC is equal to C du1 by dt. So we need a relation between, for this, when we started the problem, we wanted a relation between IC and U1. So here we have a relation between IC and U1. So that is nothing but IC equal to C D U1 by dt. So this gives a relation between output and input. Now this is a first order system, this is a linear system, and this is a first order system.